Hi, second grade. We are back subtracting some more today, and we started looking ahead at our learning target. So as we look at our learning target today, we're going to read it out loud, and then we're going to break it up a little bit and review some of those little pieces so we have a better idea of what that's going to look like today, different than what it was yesterday. I can subtract a one-digit number from a two-digit number. And yesterday we talked about that subtraction. And what do we know about it? Right. So we're taking away or we're finding the difference when we are subtracting. What is that one-digit number? It's that number that has just one digit. That number in that number in the ones place. So maybe 5, maybe 8, maybe 1, maybe 6, maybe 7. Could be any of those numbers, anywhere from 0 to 9, right? And including 9, okay? And then we take a look at that two-digit number. So we're taking these one digits from these two-digit numbers. Can you all think of a two-digit number? 32 is a two-digit number. Absolutely. It has a tens place and it has a number in the ones place. It has two digits. So we know that that two-digit number is going to be what in that one-digit number? Bigger. So we're going to take that one digit from a bigger two-digit number today. Now yesterday we were taking away tens from a two-digit number, and I just want us to refresh our memory a little bit because we were solving it in so many different ways using different models. We were using our base 10, we were using our number line, we were even using partial differences, thinking differently about those partial sums that we did, a couple weeks ago. So as we look at these different models to help us solve this work, one thing that was super helpful was to see this base 10 model, to see that we were taking our tens away, but we're not taking any of those ones away, so that we knew that pattern that was happening. Today, I want us to make sure that we're continuing to look at that part of I want us to continue to look, I can't get my words out today. I want us to continue to look at how we can use that base 10 model to help us see those patterns in our work and help us understand a little bit more about what we're doing today as we're taking those one digits from those two digits. So first thing we're going to do is we're going to take a look at a base 10 model right up here. What do you notice about this number right here? This is a model representing a number. What do you notice about it? There were 42. What was the number 42? How do you know it was the number 42? Okay, 10, 20, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 40, 41, and 42. What's the number 42? Absolutely. What else do you notice about that number or that model? What do you mean we crossed off 5? 5 tens or 5 ones? 5 ones. 1, 2, 3, 4, 5. Yes, that means we're subtracting 5. We crossed those out and we were subtracting it. What else do you notice? You have 37 left. Where is that 37? 30, 31, 32, 33, 34, 35, 36, 37. So when we start at 42, we take away 5, we get 37 back. But that looks a little different than that one over there. What do you notice that's different about this model? Ooh, yeah, normally the number 42, if we were just going to draw the most efficient way to make the number 42, we would draw it like that. Why do you think I drew it like this? Oh, I needed to take away 5 ones, but how many ones would I have had if I was looking at this model? I would only have 2. I don't have enough ones, do I? When I don't have enough ones, what did I do to help me get enough ones? I took away that 10 and I traded it for 10 ones. We know that with all of our work that we've been doing, don't we, second grade? We know that one of these is the same as 10 of these. So we can trade them out. Just like a dime can be traded out for 10 pennies, we can trade a stick of 10 for 10 ones, and it's still the same thing. 42, 10, 20, 30, 40, 41, 42. It's the same as 10, 20, 30, 31, 32, 33, 34. Help me count, guys. 35, 36, 37, 38, 39, 40, 41, 42. It's the same number. It's just represented a different way. So as we take a look at our work today, look carefully to see if what you're needing to take away is bigger than the ones that you have. And if you do, you may need to tweak your model just a little bit to make it easier to subtract. Just like yesterday, I want you to find the model that works best for you to solve these problems. So we're going to go ahead and get started, and I'm going to be coming around and listening for you and seeing which ways you are solving it to make it easiest to solve. And then we will share those and find how they're the same, but then also how they're different. We might even be able to use one to help us understand another. Our first problem today is 37. Take away 8 equals, go ahead and solve. Where is your 37 in your model? What did you have to do first? What are you taking away? How are you showing that in your model? Where are you starting on that number line? What did you take away first? What did you take away then? So where is the 8 that you took away? What are you doing to help yourself solve that? And how are you showing that in your work? Where is your 42 in your model? Or your 37 in your model, I'm sorry. Where is the 8 that you took away? We're going to come together and start showing our thinking. Remember that if you're at home, please feel free to pause the video and resume it as soon as you are ready to share your thinking and to look at some different ways of solving it. Let's go ahead and start over here. We have somebody who used a base 10 model. What did you do, or how did you draw your base 10s to show 37? Okay, 3 10s, 3, 4, 5, 6, 7. Okay, so your 3 10s and your 7 1s. All right, then what did you do? Oh, for those of you who couldn't hear that friend, they said, well, I needed to take away 8, but I only had 7 1s. I didn't have enough. So I had to take away or break apart my 10, and I put 10 1s in its place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we crossed it off and we put that over there. Okay? Then what did you do? Does that still make 37? Where are your 3 10s now? 10, 20, 30, and then you have your 7 1s. Very good. All right, so then what did you do? You needed to take away 8. So what did that look like when you were showing your work? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So you had your 37. You took away your 8 after you broke apart your 10. Busted up, right? And what did you have left? You see your 2 10s. And how many 1s did you have left? Your 7 8, 9 ones. So what is your difference between those numbers? When you start at 37, you take away 8, you have 29. 2 tens and 1, 2, 3, 4, 5, 6, 7. Don't forget these over here. 8, 9, 29. I'm seeing some wiggle waggles over there. Who else used the base 10 blocks to solve them? Ah, but you did yours a little different, didn't you? You just took that 1 away from that 10 and knew you had 9 left. All right. What did you do to show with a different model? What did your model look like? Okay. A number line. Gotta love that number line, don't we? All right, where did you start on your number line? 37. Okay, and why did you start at 37? Because your equation says 37 take away 8. So which way are you going to go? Are you going to go right or left? All right, and so when you go left, what are you going to do first? Why did you make a big jump of 7? Ah, because when you're at 37, if you take away those 7, then you're at 30. Ho ho, very smart. Okay. And then what did you do next? Getting that 10 as a friend, right? What did you do next? Okay, so you knew you had 8. You took away that 7. So you still had to take away 1 more. And if you're at 30 and you take away 1 more, what do you land on? 29. So let's go back to our equation. Make sure we have all of those parts, right, friends? Where did you start? 37. Where's the 37 on that number line? Right here, okay? And then what did you do? You took away 8. So where is your 8 in that number line? Anybody see that 8? It's the 7 and the 1. And then where is your difference? There's that 29. So when we start at 37, take away 8, we land on 29. How are these two ways the same, and how are they different? They both started at 37. So this friend had 37 with their base 10 blocks. This one started at 37 on the number line. What else do you notice? They both took away 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 7 and 1 more makes 8. Oh, all right. This friend landed on 29. This friend had 2 tens and 9 ones left. So they're very similar, but how are they different? This friend had to break up a 10 to take away, right? Absolutely. This friend just got to a friendly number. They got to a 10, right? So someone broke a 10 up. This friend jumped to a 10 to make a 10 to make it easier to subtract. Both of these ways are helping solve for the unknown. They're helping take that 1 digit away from that 2 digit. We remember, if we don't have enough of those ones, we may have to break up a 10 to get to that. But you can also use that fantastic number line to do that same thing. Let's see if we can take this learning and apply it to the next problem. Ready? Your next one says 34 take away 9 equals blank. I'm going to ask you some of these same questions. So when you're solving your work, I want you to be able to explain, where is the 34? Where is the 9 you're taking away in your model? Where is the unknown in your model? What did you have to do to make it easier to add? So our friend here broke up that 10 to make it easier to add. This friend made a 10 to make it easier to add, or jumped to a 10 to make it easier, not to add, to subtract. So as you're solving 34 take away 9 equals blank, I want you making sure that each of those numbers is in your model, and you're labeling that in your model. How we're circling, and we're making sure that we show where everything is. Go ahead and solve that problem. We're going to come back in just a few moments. Remember, at home, if we're moving too fast, Please feel free to pause us and resume us when you're ready to look at the different strategies. What did you do first? And how did you show 34? Then what did you do? Why couldn't you just take that away? Why couldn't you just leave your 10s? Ooh, so what did you have to do next? Where is that 9 that you took away? And where's your unknown? What do you have left? I see 2 number lines here, both of you sitting next to each other. So much fun. But they look different. Talk to me about these 2 number lines. Where are your 34s? And what did you do first? What did you do first? Ah, that's the same, isn't it? What did you do next to take away that 9? How is that different from what you did? Did you both get the same answer? Which one would be more efficient? How do we know that that works? All right, friends, let's come together. Let's first show that base 10. A lot of us are using those base 10s, makes it a little bit easier to solve. One thing I want to ask, when you are using these and your 1s, you're not crossing them off, are you? What are you doing to show that? You're moving them away, right? You're tucking them away, putting them away for a rainy day. So we're just showing that we're crossing them off because we're taking them away if we're actually using the blocks in front of us. So when we're showing it, we're crossing it off. When we're doing it, we're taking it away. How do we show 34 with our base 10 blocks? And how do we know that this shows 34? 10, 20, 30. Ooh, help me count this. 10, 20, 30, 31, 32, 33, 34. 3 10s, 4 1s. 3 10s, 4 1s. Okay? And what are we doing next? How are we going to take that 9 away? Oh, what did you have to do? Why did you break up that 10? Because there wasn't enough. How did you know there wasn't enough? Because 9 is bigger than 4, right? I can't take away 9 from 4 because I don't have enough. It's just a bigger number, right? So what did you do next? We crossed that one off and we put 10 1s in its place because 10 1s and 1 10 are the same, right? They're just showing a different way, a different representation. All right, so how are we going to take away that 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. And what did you see that you had left? 2 10s, 5 1s. And what does 2 10s and 5 1s make? 2 10s, 5 1s makes the number 25. Seeing some wiggle waggles. Ooh. Well, I found one little spot in our room that both my friends use the number line. So I'm actually going to show 2 different number lines today. And I want us to see how those can help us make some connections to what we're doing. So let's go ahead and show our first one. What did you do first? Started at 34. And why did you start at 34? Because in our equation, we have 34 at the beginning, and we're taking away 9. So how did you show that we took away 9? Why did you make a jump of 4? Okay, because it got you to your 30. That 10 is a friend, right? What did you do next? Made jumps to get to 9. So this is your 4, 5, 6, 7, 8, 9. So I had to take away 1, 2, 3, 4, 5. Okay? And what did you land on? This is 29, 28, 27, 26, 25. Where's your 9 in your number line? Okay, so we had the 34, took away the 9 and on 25, and we broke that up, didn't we? Breaking it up, there's that 4 and that 5 more that you're taking away. What did you do though with your number line? And then we'll see how all of the ways are similar and how they're different. Start at 34 as well. Okay, and what did you do? Took away 4 to get to 30. 10 is a friend, right? And then what did you do? You knew that 4 plus 5 equaled 9, so you took away 5. All right, and where did you land? Ooh, 25. And how did you know that you were going to be landing on 25? Because 5 and 5 is 10. 30, take away 5 is going to be 25. And again, where is your 9 in your number line? The 4 and the 5. Let's take a peek at these ways of solving this work. What do you notice about all of them? They all have 25 as the answer. They all start at 34. Base 10 and number line. All right, so these two are getting to a 10 again, and then they're taking away the extras. Where are the 5 and the 4 in this work that you see? There's the 5 and the 4 to get to that 10. In fact, if we looked at this, where do you see getting to a 10 there? Right? So once they took this 5 away, we could actually see that there's 10 ones right there, right? If we looked really hard. This one was a lot easier to break apart that 10 to make those ones. Friends, as we take away these 1 digits from these 2 digits, sometimes we have to group them up in different ways. We do regroup. That means group them again. When we group them again, we want to make sure that we see where those groups are. So if we're crossing off those sticks of 10, we want to show that there's 10 ones that took their place. If we're making a 10 or we're getting to a 10, we want to see where those 2 chunks are to make sure that we are showing all the parts of the equation that we're doing. Today, your exit task is to use a model, can be a number line, can be base 10, whatever you want to do, to solve 27, take away 8 equals blank. Remember again, you're on your own to show 27, take away 8 equals blank. Remember to do that, and then you can do your independent practice on your own. I look forward to seeing how you're solving it, and we'll dive into some more tomorrow.